Okay, this is the last of the 3 parts of the recording, and we're going to do the last 3 pages. I am going to go probably too quickly for most people. So when I'm making a recording, I go much more quickly, and my assumption is, my hope is that you watch the recording and you also think about it, go back and think about it. Okay, so an electrician charges this fee, $75 for each home visit he makes, and a $35 per hour fee for each hour he works. So let's draw a bar diagram. The electrician shows up to the house and he charges this much. And then he stays at the house, and every hour that he works, 1 hour, 2 hours, 3 hours, every hour that he works, he's going to charge $35. So let's see, he shows up to the house and he says, hello, you owe me $75. But you don't have to pay the electrician over and over. That's what he charges when he comes to your house. He comes in, he has to get in a van, he has to get all his stuff, he has to drive to your house, and he says, you give me 75 bucks before I do anything else. That's what you owe me for the home visit. And then he starts working, and every hour that he works, he makes $35. Incidentally, this is about what electricians cost. So electrician is definitely a good business to get into, especially like home electrician. Like TV electrician, not so much these days. I know somebody who's a TV electrician, they can't find any work because all the TVs are LEDs now. Okay, so 75, and this would be for 3 hours. So let's turn that into an equation. So it would be y equals $75 to start with plus $35 every hour, right? So this would be $35 times 3, but this equation says 75 plus 35 every hour. And the reason I kind of get frustrated is because we've been talking about this being the slope and the intercept for a really long time now. And the slope is how fast it happens, and it's the number that's in front of the h. So the slope is 35. It's also what tells you what the pattern is. So it goes up by 35 every time. And then this is where it starts. It would start at 75, and that's for 0 hours of work. So when I say it happens where x is 0, it means if we work no hours at all, h is 0, and so it started out at 75, and then it's going to go up from there. Okay, so that was my linear equation. It's a linear equation because it's mx plus b, and mx plus b makes a straight line. So this is the middle thing that we talked about. Straight line functions are mx plus b. The electrician decides that he wants to change his hourly rate to $42 an hour, write his new linear model. Well, he didn't change how much he charged when he got to your house. He just changed how much money he charged for each hour. So if you're reading this right, it's as simple as the electrician makes $75 to come to your house plus $42 per hour. The equation is telling you what it means. $75 to show up plus $42 per hour. Okay, and then go ahead, man. No, he changed it to 42. The electrician decides he wants to change his hourly rate to $42 an hour, write his new linear model. Okay, Kwan owned a design firm for the last 15 years. The graph shows the profit in dollars Kwan made with his design company as a function of time. We're going to have to do something with this function. All right, so Kwan is doing something with this graph. Whoops, I moved everything. So what is the domain and the range of this function? I'd like to remind you that the domain goes, I can't remember where the domain goes, if it goes left and right or if it goes up and down. The domain, I think, is the lefty-righty numbers, and the range are the uppy-downy numbers. Okay, so I'm going to look at the lefty-righty numbers, and these are bigger. This is a better graph than the other one. The lefty-righty numbers are in between 2 and, don't stop at 14, it actually goes all the way up to 15. Okay, so it goes between 2 and 15. In other words, the domain is more than 2 but less than 15. The range are the uppy-downy numbers. The uppy-downy numbers start at 0 and they go all the way up to, they'll go up to 50, but I only want to look at the data. So the data only goes up to around 40, would you call that 41 or 42? I think that's 42. So between 0 and 42. So the range are the numbers where the data lives up and down. The smallest range is 0 because the data lives there, and the biggest range, uppy-downy, is 42. The name of this assignment was Domain and Range from a Graph, and it is also in your list of review assignments. Domain and range from a graph. Okay, next question. List 3 solutions to the equation graphed below. And there doesn't appear to be a graph. Is it on the next page? Yes, it is. List 3 solutions to the equation graph below. That's a bizarre question. Let's draw some more lines because we need more lines. So I'm going to put, I'm going to say just skip this. This is a badly worded question. No intersects. So whoever did this, they should have drawn another line because I want to figure out where they intersect. Okay, so skip that one. What is the average rate of change over the interval between 1 and 8? Now remember, this is the lefty-righty number. So from left to right. So I'm going to look for the number 1 over here and the number 8 over here. So I'm going to go between 1 on the left and 8 on the right. Okay, that's the domain number. So I'm looking between here and here. Okay, so where am I looking? I'm looking between 1, 1, and 8. So I want to draw my triangle to go between those two. So it's going to start here at 1, put a 1, and then I'm going to go all the way up to 8, put a dotted 8, and that's going to be my run right there. So let's make a slope triangle, and that's going to give me my rate of change. So this is this side of the triangle, and here's the run of the triangle, and here's the rise of the triangle, and then you can highlight that in. The key to average rate is that I'm not going to, I don't care about what the line does in between there. So I have it where it is at 1, and I have where it is at 8, and there's my function triangle, and I'm going to go ahead and do this one and get this rise in the run. I was yelling at you yesterday, don't count the squares, but these go by ones, 1, 2, 3, 4, 5, so I can count the squares, and that's fine. I don't need to. What's the difference between 1 and 8? 7. To go from 1 to 8, you count by 7. And then this one goes from 2 up to 6. What's the difference between 2 and 6 is 4. Or I could count the squares if I wasn't good at subtracting. 1, 2, 3, 4. Okay, that's not necessary to count the squares if you know your y2 minus y1. So what is this average rate of change? Is it 4 over 7 or is it 7 over 4? It's 4 over 7. You guys are really great at average rate of change. There's like 2 questions on the final. There's a lot of things about slope though. Okay, number 21. I'm glad you guys are so excited about this. This is thrilling. Math is fantastic. On the other hand, like I'm giving you the answers to the test. It's really the best thing I can think of to do. Draw the line of best fit for this scatter plot. Blam. Find the equation of your best fit line. Okay, so the equation of a best fit line. Here are the steps again. I need to know 2 things. Where does the line start? That's the y-intercept. How does the line change? That's the slope. And then once I have those 2 things, the equation of a straight line is y equals mx plus b. Okay, so I'm going to figure out where it starts. I'm going to figure out how fast it's changing. If I know those 2 things, then I'll know what the line is. Okay, and it's really not that bad. Where does the line start? Starts at 100. Okay, so I know my equation starts at 100. Now the harder part is definitely getting the rise run triangle, but that's not that bad either. So to get the slope, I need the rise and the run, and to do that, I'm going to draw a triangle. My triangle is going to look like this. It's going to go sideways by 25. I automatically knew it was going sideways because this went from 0 all the way up to 25 right here. And then on the uppy downy, I'm not going to count squares. I'm going to start here at 100 and I'm going to end here at 600. So this line uppy downy, the change is from 100 to 600. So it's going to go from 100 down here up to 600 up here. 600 up here. And the rise is neither one of those numbers. The rise is how much it changed in between those 2 numbers. So how much did it change in between? My arrow here, I have to rotate it. It's kind of annoying to rotate these arrows, but there we go. I think it looks good when you're done. Okay, how far from 100 to 600? 500. Okay, we have got this. No problem. So the rise was 500. And the run was the distance side to side, that was 25. And that means the rise over the run is 500 over 25, which I can use any calculator in the universe in order to get 20. And that means the equation of my line is 20x plus 100 to start with. Okay, so let's label the terms. So this is term 1. So let's see, 20 is about the right size. Term 1, 1, 2, 3, 4, 5. Okay, so that's the first 5 terms. What's the 6th term? -7, -3, 1, 5, 9, 13, because it goes by 4s. Okay, now this function, a of n, is telling you that you could input n and input n, okay, input n equals the number of term. Okay, what's the term that we're looking for? Which number of term are we looking for? Okay, it says, what is the 13? So the term number that I'm looking for is 13. Now, if I wanted to, and I didn't like using the function, I could just keep the sequence going. So I could go all the way up 6. Let me put 6 all the way over here. 6, 7, 8, 9, 10, 11, 12, 13. Okay, so I could continue the sequence and then I would figure out what it is. These are for people who don't know math because they're not lazy. If they were lazy, they would never do it this way. So the next one is 13, 17, 21, 25, 29. I'm going by 4s each time. 33, I have room for a space. 33, 37, 41. Okay, so my answer is going to be 41. But let's see what we get if I input that into the function. A of 13 equals -7 plus 6 times 13 minus 1. So all I did was put 13 in where n was. At the end, I should get 41 because I know that the answer is 41. And we are officially out of time. So this is going to be -7 plus 6 times 12. That's -7 plus 72. And that is, boy, whoever did this function rule looks like they got it wrong. Oh, yeah, they totes got this wrong. The function should not have been 6, it should have been 4. But this one was 65. Okay, that is the end of this recording.